Excuse me. Good afternoon, good evening. We are going to predict the products of chemical reactions. Okay, this requires that you know how to write a balanced chemical equation and you know how to identify the parts or identify the type of chemical reaction. All right, so get ready to take notes. As usual, write down everything the way I write it. You should have questions on this. This is something that a lot of students make a lot of mistakes on initially. So it makes it fun, okay? To be honest with you, it makes it fun. So I'm just going to make a new note here. And let's call this predicting products of chemical reactions, all right? Predicting the products of chemical reactions. In order to do this, you must be able to identify the type of reaction. So we're just going to jump into some examples. There's no other way to do it. So let's just look at examples and I'll talk about what I noticed with each example. All right, let's say that first example, I've got, other thing is remember diatomic molecules. All right, remember diatomic molecules. Green, gold, ha. All right, let's say that in our first example, we have, oh my gosh, I can't think of anything. Strontium plus oxygen yields, all right? Well, let's look at that. That's like an element plus an element, right? So what's the only thing this substance, these two elements can do is this, they can combine, right? So this is a synthesis reaction. And what we would see would be strontium oxide, right? Okay. So strontium is Sr. It's by itself. Is it diatomic? No, leave it alone. Oxygen is O. It's by itself. Is it diatomic? Yes, give it a 2. Yields strontium oxide. This is ionic. We need symbols and charges, okay? Well, strontium is an alkaline earth metal, so that's a charge of 2+. Oxide is the oxygen ion, so recall that that will be SRO, okay? This is a 2, this is a 2. Go ahead and teach you guys a little bit more. This is a metal, guys. It's going to be solid unless dissolved in water, and then it would be aqueous. Oxygen is a gas. This is ionic. It will be solid unless in water, okay? All right, let's look at another example. Let's have gallium reacts with bromine. All right. So I've got, once again, an element, gallium. It's by itself. Is it diatomic? No, leave it alone. It's a metal. It'll probably be a solid. Reacts with bromine. Bromine is one of the only 2 elemental liquids. Bromine is actually a liquid. And when we put those together, once again, notice you've got element plus element. So the only thing these guys can do is combine, right? Once again, we've got the synthesis. When they combine, we'll have gallium bromide, right? It's going to be that ionic equation with the metal and the non-metal. So we need the symbol and the charge, the symbol and the charge. Right, that's a 3+. So I end up with GaBr3. It's ionic, so it's either going to be the solid unless it's dissolved in water, for the most part, okay? Notice I've got 2 bromines and 3 bromines here, so I'll put a 3 here to make that a 6, 2 here to make that a 6, and a 2 here to get that balance, all right? So both of those examples involved an element reacting with an element. We recognize that that is synthesis. We combine them into a compound. They're pretty much all going to be ionic. So we got the symbols and the charges for the most part. We just wrote the balanced equation, right? In the second example, we had an element, gallium, reacted with an element, bromine, who is diatomic. Thus, they combined in a synthesis, making gallium bromide, symbol charge, and then we balance the equation. Okay, let's look at another example. All right. And this would be, let's say that we've got magnesium oxide decomposes. Okay, and it's telling us, so SCMGO, the only thing it can do, right, it's just a compound reacting. It's got to decompose, right? The only thing it can do is break down. So it'll break down into magnesium, Mg, and Mg, it's by itself. Is it diatomic? No, leave it alone. And what element? Oxygen. It's by itself. Is it diatomic? Yes, 2. All right, we got 2 oxygens produced. We need 2 reacting and then 2 Mgs. Excuse me. Let's do Na2CO3, metal carbonate. All right, sodium is the metal, CO3 is the carbonate. Whenever they decompose, we will get the metal oxide and carbon dioxide. It's just something that must be remembered. So I'll get the metal oxide. That will be sodium oxide. It's ionic, so let's get the symbols. Sodium is Na, excuse me. Oxide is O2 negative. So we're going to put Na2O, right? Na2O, and carbon dioxide, that's CO2. All right. How do you feel about that? Okay. What if I have Ki yields? Well, the only thing it can do is break down. So we'll break down into potassium. It's by itself. Is it diatomic? No. Leave it alone. And iodine. It's by itself. Is it diatomic? Yes. Give it a 2. We have diatomic iodine. Therefore, we need a 2 here and a 2 here. Right? So real simple. Let's look at some more examples. Let's change it up. All right. Let's say that, let's see. Some of these reactions might not actually occur. I'm not going to worry about it. Let's say that zinc reacts with sodium hydroxide. Okay. So we've got zinc. It's by itself. Is it diatomic? No, leave it alone. And sodium hydroxide. Sodium is Na with a +1. Hydroxide is OH. The -1, it's NaOH. Now, pay attention here. We have an element and a compound. Okay? So we know that we've got a single replacement. Okay? So I need to think about who will be replaced. You need to realize that cations replace cations and anions replace anions. Zinc is a 2 plus, sodium is a 1 plus, OH is a 1 negative. Therefore, my zinc will replace my sodium, and sodium will be by itself. This is assuming this reaction would occur. Not all reactions would occur, to be honest with you. This one, if it was in solution. Okay, so let's rewrite that. We've got zinc plus sodium hydroxide. What we're going to have is sodium by itself, okay, and then zinc will be with hydroxide. But we need to write that. So we've got zinc, right? So zinc moved in, sodium moved out. Now zinc, who was by himself, just rewriting the reactants, has moved in. So sodium moved out, and now zinc is with hydroxide. Well, zinc is a 2, hydroxide is a -1, so that would make ZnOH 2. And since we have the 2 OHs produced, we need a 2 here, and then we would need 2 sodiums here. Okay? Let's look at another single replacement. Let's say that we've got, let's say that we've got, I don't know, silver plus lead to nitrate, right? Well, we see an element and a compound. So we know that's single replacement. So we need to remember that positives replace positives, metals replace metals, cations replace cations, and anions replace anions. So silver is positive, right? Lead 2 is positive, and nitrate is negative. So silver will take the place of lead and kick lead out, and silver will be with nitrate and lead will be by itself. Let's look at this in a different way. Silver is Ag, it's by itself. Is it diatomic? No, leave it alone. Reacts with lead to nitrate. Well, that's lead with a 2 charge, nitrate with a -1 charge. So that makes PbNO3 parentheses 2. Okay, now we'll look at this again in a different way. Silver is 1 plus, lead is 2 plus, nitrate is 1 negative. Silver is going to move in and kick lead out, okay? So we will now have lead by itself. Is it diatomic? No, leave it alone. And now silver with a 1 charge will be with nitrate with a 1 charge to make AgNO3. There's 2 nitrates over here, so I need a 2 here, so I need a 2 in front of my silver. Let's look at another one. Let's say that fluorine reacts with calcium chloride. All right. So fluorine is F. It's by itself and it is diatomic. Reacts with calcium chloride. That's calcium 2 plus, chloride 1 negative to make CaCl2 to produce. Well, this is once again a single replacement because it's an element and a compound. Let's determine who will replace who. Fluorine is a negative. The copper is the calcium, is the positive, and the chloride is the negative. So this time the fluorine will take the place of the chlorine and the chlorine will be out by itself, okay? So we will have calcium will be with the fluoride Remember, it will never be fluoride calcium. It's always the metal or the positive cation first. And then chlorine will be by itself. Okay? I heard something. Okay, so what we have here is fluorine, diatomic F2, reacts with calcium chloride to produce, now calcium, remember negative, positive, negative, calcium will be with fluorine, and chlorine will be by himself. So I'll have CaF2, that's because calcium is a 2 plus and F is a negative, and chlorine is by itself. Is it diatomic? Yes. Okay, you're doing good. This takes practice. We're almost finished. Double replacement. Okay, so let's look at how these are going to look. We will have something like aluminum oxide reacts with calcium. I'm just making this up, okay? Calcium bromide. Okay, all right. So what we see is we have a compound. These are examples. So a compound plus a compound, right? So we've learned that that's a double replacement reaction, right? We just wrote that. You don't need to write this again. Double replacement. All right, aluminum oxide, symbol, charge, right? Okay, that's going to be Al2O3, reacts with calcium bromide, symbol, charge. Okay, that's going to be CaBr2. Okay, now what's going to happen is these guys are going to switch places, all right? The aluminum, the positive aluminum, will go with the negative bromide, and then the positive calcium will go with the negative oxide, okay? So remember, it's always positive first. So I will have Al will go with Br. So here's my aluminum ion. Here's my bromide ion. Look at the charges. We have AlBr3. And the calcium ion will go with the oxide ion. We have CaO. All right. Now, cool. You just got to get that guy balanced. It does not matter what order I write my products in. The CaO could have come first. Notice I've got 2 bromides here, 3 bromides here. So I'll make that equal to 6 on both sides, right? The aluminums are good. Oxides and calciums, it looks like we'll need a 3 right there. Let's do that one more time. Let's do iron to sulfate plus nitric acid. All right. So we've got a compound plus a compound, right? We know it's double replacement, so we're just going to switch places, right? So you need to write iron 2 sulfate. Figure out what it is. Iron 2 sulfate, right? You were already supposed to learn how to write formulas, so that's not what we're teaching now. Nitric acid, no hydro, oxy, HNO3. Okay, hopefully you learned how to do this. Now notice that we'll put this positive with this negative, and we will put this positive with this negative. We are assuming these reactions occur, okay? It's not the point. So iron is going to go with nitrate. Iron has a charge of 2. Nitrate has a charge of 1. That makes FeNO3, 2. And hydrogen is going to go with sulfate, hydrogen, sulfate. Look at the charges, H2SO4. We need a 2 here and a 2 here. Something's wrong. Why are there 2 sulfates over here? Oh, we don't need this 2 right there. That's better. Okay. All right. Last one, last example is going to be much easier. And this will be combustion, particularly of hydrocarbons. All right. So what's a hydrocarbon? A compound that has C's and H's, or a compound that has C's, H's, and O's. When it combusts, what does it react with? You should know this. Plus O2, plus O2, plus O2. Okay, so when you see combustion, you know that oxygen is a reactant. Well, whenever a hydrocarbon, look at what a hydrocarbon is. We're almost finished here. Carbons and hydrogens, carbons and hydrogens, carbons, hydrogens, and oxygens. Whenever they combust, you can't see me because it's dark in here, you will always get carbon dioxide and water. Okay? Carbon dioxide and water, carbon dioxide and water. Okay? So if I say candle wax combusts, you wouldn't know this, but candle wax is like C18, 8, I don't even know. Maybe I don't want to do that. C20, I don't know. Maybe it's C20, H38, 42. Let's not do that example. Oh, let's do this example. If I say aluminum combusts, or the combustion of aluminum, well, then I would do Al plus O2. Well, notice that I also have a synthesis reaction because of an element plus an element, right? So in this case, they don't have a hydrocarbon, and we get aluminum oxide, Al2O3, right? Because aluminum is a 3, oxide is a 2. And I would end up with a 3 here, a 2 here, and a 4 here. All right? You got to practice. So what you can do is, you know, look up some worksheets. You can look at the worksheet that I'm going to attach that we'll look at tomorrow, okay? Right on. See ya. Oh my gosh, it's so dark. See ya.